Okay, we're going to talk about absolute value functions and their graphs. A couple of things we're going to talk about. Just as the absolute value of x is the distance from 0, the absolute value of f of x, or absolute value of f of x, gives the distance that graph is away from the y equals 0 line, which is the x-axis. The simplest example of an absolute value function is f of x equals absolute value of x. The graph of the absolute value of a linear function in two variables is v-shaped and symmetric about the vertical line called the axis of symmetry. Such a graph has either a single maximum point or a single minimum point called the vertex. So very similar to our quadratic functions we graphed before, where we had the axis of symmetry and the vertex and all that kind of stuff in it. So, So, let's look at a couple more concepts. Key concept: the absolute value parent function. That means the original function is absolute value of x. If they give us this function notation, here's our table of values. Everything's positive. They give us over here x at a negative x, x is greater than 0, x is less than 0. Notice here, I always think about is this the slope of 1. If you notice here, we're going to start at 0, 0, go up 1 over 1 all the way through. Up 1 over 1 all the way through. That's what the absolute value function looks like. Now, what is the graph of the absolute value function, this, and how is the graph different from this? Okay, well, let me draw an axis real quick here. Here's my axis. Okay. Now, what happens here is, if I drew my absolute value function, we know that this goes up 1 over 1. It's still up 1 over 1. Notice there's a 1 in front of here. But this is a minus 4, so we're going to go down 4 units. And we're going to start our graph right here. We're going to go up 1 over 1. Up 1 over 1. Over 1. And we're going to go both directions like that. Up 1 over 1. Up 1 over 1. And now we're going to draw our graph in there. Hopefully my lines will go somewhat through my points. There's one. Here's another one. Arrows at the end. So you can see the point. What happens here? How is this graph related? Well, I took the whole graph and moved it down 4 units. So let's look at the next one here. It says, what is the graph of f of x of this, and how is the graph different from the parent function? Well, we already did minus. What do you think is going to happen here? If I graph this out, it's going to take the whole graph and move it up 2 units. So in other words, we're going to start at 2, and we're going to go up 1 over 1. And so my graph, I'm not going to use it right here, is going to look something like that as you go. So now, do transformations of the form of this affect the axis of symmetry? Axis of symmetry on here, when it goes up or down, doesn't change. That's still going to be at 0. So that doesn't change. So no. But it does change where the graph starts and ends. Now, a couple key concepts of graphing here. It says vertical translation. This is the numbers on the outside. So plus k or minus k. Horizontal translation is minus h or plus h. Moves left or right. Just like the previous section, A and A in front. Vertical is stretch, compression, and then a negative and an x inside or outside is your reflection. Now, if I start it with this one, a lot of times what I do is I start with my graph, original graph. So that's a little slanted, but that's okay. So my original graph, oops, let me try that again here. I'm going to say this is my original graph. Okay, this is f of x. Now this is a translation. We're going to move it 2 units and then up 1 unit. So in other words, I'm going to take this point which starts at 0, 0, I always say. We're going to move it 2 units to the right since it's minus. And we're going to move it up 1 unit. So my starting point right there is there. Then we go up 1 over 1. Up 1 over 1. Up 1 over 1 this way. Up 1 over 1. And I know my points are not exact, but it kind of gives you the viewpoint of what we're going to do here. So my new graph looks something like this. And I'm going to move it over just a hair because there, it looks a little better. So this is my new graph. I move the whole graph over 2 units and up 1 unit. What is the graph of each function? Well, what is this going to do? Okay, a couple things. If I was graphing this out, I'm going to do both of them on the same graph. We know our original function starts at 0, 0. This is not going to move, this graph is not going to move it up or down any, but with the 2 in front now, what it's going to do is it's going to change and stretch my graph out. So I'm going to go up 2 units and over 1 this time. Up 2, over 1. So therefore, my new graph for part A would look like that. This is part A. I'm going to put an A on here. And I should draw, I'm just going to draw a different one here. See if I have a different color. Let's just do blue. If I go up 1 over 1, oops. Didn't want to do that. Undo line. Okay. Let me do my points first. Up 1 over 1. Up 1 over 1. Just so you can see the difference here. My original graph would look like this. This is my original one. So this is really f of x. This is a. Now b, what b does here is a little different. Not a lot. What b does is, okay, it's going to flip it. And it's on the outside. It's going to take my y points and flip it down. And it's going to change its slope is down 2 over 3. So we're going to go down 2. Down 2. I'm just making some points here. So now if I want to draw that graph, and I'm just going to throw a different color out there again. Let's go orange. My graph would look like that. So what happened? Okay, what is the graph of each function? Okay, this green was my original. With the 2 in front, it stretched it up. With the 2/3 and negative 2/3 in front, it's flipped it and it stretched it out a little bit as it goes. Make it a little wider. Making a set of points. So as you make your points here, what you might want to do is say, okay, how do I going to graph this? I might make a table of values. So x and y. In the previous problem, we have -3, -2, -1, 0, 1, 2, 3. And now the absolute value is going to be 3, 2, 1, 0, 1, 2, 3. Now when I go into here and graph this, let's say 2 is going to take all my y coordinates and stretch them. So no, I can say my y prime, let's say my new y coordinates, instead of being at 3 now, we're going to be at 6. We're going to double these, 4, 2, 0, 2, 4, and 6. And I would graph a -3 and 6. -3 and 6. I'd graph those as I go. And on the bottom, we'll do the same thing. We're going to multiply all the coordinates by a -2/3 as you go through. Now, a key concept, general form of absolute value function is this: y equals a times x minus h plus k. The stretch or compression factor is absolute value of a. The vertex is h and k. And the axis of symmetry is y equals x. X equals h, I mean. Without graphing, what is the vertex and axis of symmetry of the graph of this? How is the parent function transformed? Well, my vertex is on here, going to be what makes it 0 on the number on the outside, so it'll be 2, 4. It's my vertex. My axis of symmetry is x equals 2. And how is this transformed? It's moved to the right. I'm just going to say this. This part is going to move it to the right 2 units. I'm going to put an arrow. This part is going to move it up 4 units, and this is going to stretch it vertically 3 times by a factor of 3. So we would have to multiply the y coordinates by 3. add 2 to the x coordinates and add 4 to the y coordinates. So a couple of little options as you go. What is the equation of the absolute value function? Well, let's see here. My vertex is 1 over 1 and then up 1, 2, 3, 4, 5. It looks like 4. So I would have y equals absolute value of x plus 1 plus 4. So it moved up 4. But then what happens here is we're going to have flipped upside down too on the y-axis, so that goes in front, so it'll be this going through it. It has to go in negative in front because it flipped upside down. Let's look at this one. What is the equation of the absolute value function? Now this one looked like it moved over 1, 2, and down 1, so and it's going up, so y equals, and I'm going to come back to this one in a little bit here. Let's just see this. First of all, it moved over 2, so x minus 2, and then down 1 minus 1. But now when we look at this, and I'm just going to look over here, this goes up 1 over 3. So it stretched it vertically, stretched it out pretty strong there. So it's going to go up 1 over 3. So that means this number in front here has to be a 1/3 because it's going up 1 over 3. And that's what I wanted to check on here. This one goes down 2, 1, 2, 3, 4, 5, 6, so 1/3. So this is a little different too. So it flipped it, but it's going to be a 1/3 in front because of the stretching out of the graph. So we have to look at those two as we go. And that finishes off that section. Hopefully that gets you going. A little harder sections here, so make sure you ask a lot of questions.